this is my function. We are going to be sketching the graph. But what we first want to do is check which of these four are zeros. Now, since this is a cubic, what's the most amount of zeros we're going to have? 3. Could we have less? Yeah, but we know for sure the most we have is 3. So will one of these for sure not be a 0? But more than one could possibly not be a 0 as well. But we know there are at most 3 zeros popping up. So let's check which of these are zeros. Now we're going to use the remainder theorem or synthetic division. I know it says to use remainder theorem, but I'm going to use remainder theorem for the first two, and I'm going to use synthetic division for the last two. On the test, you could choose which one you want to use. So let me show you remainder theorem, how to check zeros, or possible zeros to see if they actually are zeros. The process is basically to take this number and stick it in for x. If your output is 0, that means your remainder would be 0, which means it's a perfect factor. So we're looking for remainders of 0. So let's plug 3 into this function. Here's what it looks like. We have f of 3 is equal to, and I'm just plugging 3 in. So we have 3 cubed plus 4 times 3 squared plus 6 times 3. Alright, then we got to do the math here. So if we look at this carefully, don't we have 3 cubed here and 3 squared here? So 3 cubed, isn't that 27? And 3 squared, isn't that 9? So what we have here is negative 2 times 27 plus 4 times 3 squared, which is 9. And 6 times 3 is 18. Now again, what we're looking for is for this to equal 0. If it's not equal to 0, obviously we can just stop. But does this look like it still might be 0? Let's keep going, because at this point we can't tell for sure. I now know that's 54 negative. I know 4 times 9 is 36. So is that for sure not 0? No, looking at that, that still could be 0. Is it 0?
Yeah.
Yes, if you do the math, what you'll notice here, if you combine those, it actually equals 0. So what that means is 3 is a 0. It is a point where the graph crosses the x-axis. So is this a 0? Yes, it is. So let's put the word yes. The reason is because the output was 0 when you plugged in the possible 0. Now, could you go to on your grid and put that 0 on your grid? We know it's going to cross the x-axis at 3, so we can go over here and put a dot at 3. Yay. I know for sure my graph's going to hit that. Okay, B. Let's plug in negative 1. So f of negative 1, let's plug it in. You got negative 2 times negative 1 cubed plus 4 times negative 1 squared plus 6 times negative 1. Just got to be careful on your math here. That'd be negative 2 times, well, negative 1 cubed is positive 1. And negative 1 squared is, oh, no. Negative 1 cubed is negative 1, isn't it? Because negative 1 times negative 1 times negative 1 is a negative 1. Negative 1 squared is positive 1. And 6 times negative 1 is negative 6. So that right there, negative 1 squared is 1, and that becomes negative 6. Let's combine let's multiply these two, so it's 2. 4 times 1 is 4. And then we got minus 6. So that's 2, that's 4, that's minus 6. Does that look like it might equal 0? It does actually equal 0. So what does that tell us? It tells us that negative 1 is another 0, is one more 0. So I know that negative 1 is a 0. So negative 1 is a 0. Let's put that on our grid. Why aren't you writing anything? Huh? You going to write it later? Just make sure you do. Any questions so far? Now the next two, I'm going to use synthetic division. I'm going to use synthetic division on the next two. You get to choose on your test which method you want. Now, for these next two problems, I could keep doing remainder theorem, but I'm going to go to synthetic division. So you see another way of doing it. You get to choose on the test to use remainder theorem or synthetic division. I know it says use remainder theorem, but I'm okay with synthetic division as well. So let's do synthetic division. Let's do 0 using synthetic division. Now, the coefficients we're going to have are -2, 4, 6, and 0. Don't forget there's a 0 at the end. So that'd be -2, 4, 6, and 0. A lot of people forget that last 0. Bring the -2 down. All right, 0 times -2 is -2. Add down. Oh no, 0 times -2 is what? 0. Now add down. Isn't that 4? Okay, what's 0 times 4? 0. Add down. That's pretty easy. What's 0 times 6? 0. Okay. That was a pretty easy one. 0 is nice. Got a lot of zeros. So is that a have no remainder? Yeah, there's no remainder. So what does that mean for us? That means that 0 is one of your zeros. So we go over here and put a 0 right there. So I have 3 zeros so far. Let's check the last one. We have -2, 4, 6, and nothing, honey. Bring down the -2. Let's do synthetic division. 1 times -2 goes right here. That would be -2. Add down. 1 times +2 is 2. Add down. 1 times 8 is 8. Add down. So what does that mean? My remainder is not 0. So do you understand that's not a 0? So 1 is not where it crosses the x-axis. Alrighty, so we know that our zeros are 3, 0, and -1. We put them right there. Okay, before we sketch this, let's write the equation in intercept form. Well, if we know the zeros, do we know the factors at which it crosses the x-axis? Since I know my zeros are right here, I know which factors in intercept form it will look like. Now, first of all, do you know that -2 is your a value? And do you understand that the a value of a standard form is the same a value of a factored form? So that -2 right there in front goes along for the ride. So my function will be f of x is equal to -2 starts it off. And we have 3 zeros, so each 0 has its own factor. For factored form, which is called intercept form, you call it both, let's put our factors in here. And what you'll notice is, isn't each of these has a factor. So what is this 0 going to be written as? Well, since that's -1, we'll do the opposite of that. So since it's -1, you're going to make that a +1. This right here is 0. So go ahead, you can add or subtract 0, because have fun, it does the same thing. Add or subtract 0 to anything, it still doesn't change it. And the last one is a +3, so what's the opposite of +3? So this would be x minus 3. So just again, the -2 came from, it's this coefficient of the standard form is always the same coefficient of this form. It goes through every form and stays the same. Now, can any of these be simplified without doing FOIL? Look at this one. Can you just write that as x? Because you would never see the answer written like this. Here's how your answer would finally be written. You bring this one in front with the -2. This is how you'd write the answer. You'll just never see the other way. It just looks kind of odd. You bring the x minus 0 just as an x with the -2, and now you leave those. If I were to FOIL this all out, distribute and FOIL it, do you understand how you get back to the original? That'd be a waste. It's asking for intercept form, aka factored form. Now, since this is in factored form, since we have the zeros, do we know how the graph might look through these points? Is this going to be the disco dancer going up and down, or is this the W or M look? Well, since it's a cubic, don't you know it's looking the disco dance kind of looking one? And since it's -2 in front, doesn't that mean it's going to go downhill like that? So can you draw a graph that kind of looks like that through those 3 dots? Now, are any of those double bounces? Are they going to bounce off, or are they going through? Well, are any of them... Well, we can't tell if they're squareds. I mean, according to our function, none of them are squareds. So let's assume we go through and no bounces. Can you tell it looks something like this? Something like that. Mine's pretty darn ugly. But we know it's going to go downhill through those dots. None of mine are squared, so there's no bouncing off. And there we go. We verified some zeros, we put it in factored or intercept form, and we sketched it. This will be a benchmark for you.